Okay, so now we're going to introduce the notion of concavity. Concavity is an idea that it determines the direction that the curve turns. In this picture, the curve is increasing. In this picture, the curve is increasing, but they behave in fundamentally different ways. In this case, the curve is increasing, but it's increasing and it's getting steeper and steeper the further you go. In this case, the curve is decreasing, but it's slowing down its rate of increase. Imagine if these trends were to continue. If they were to continue, this curve would continue to get larger and larger and larger. But if this trend were to continue, the curve would eventually turn back and become smaller. These are fundamentally different behaviors, and the notion we're involving here is something called concavity. In this case, if the curve opens upward, we say this is concave up, and the symbol we'll use is concave up. This curve, if it opens downward, this curve is concave down. And the symbol we'll use is concave down. Now, there's a little piece of information I want to lay off to the side. That's going to be important for our work here in just a moment. So I want to make a little note here. A function is increasing if its derivative is greater than 0. So we know that from our notions of increasing and decreasing. A function is increasing if its derivative is greater than 0, and though we don't need to write it, a function is decreasing if its derivative is less than 0. So I want to keep that on the side for a moment because we're going to reference that in just a moment. The key notion about concavity deals with the tangent lines, but in a different way. Look at all the lines that are tangent to this curve. Well, two things. The curve is always above the tangent lines. Except at the points of tangency, the curve is always above the tangent lines. Whereas in this picture, concave down, except at the points of tangency, in this case, the curve is uniformly below all the tangent lines. The curve is below the tangents for concave down. The curve is above the tangents for concave up. And now here's the key. Consider each of these. Let's look at the curve that's concave up. Consider each of these tangent lines. This is tangent line number 1. The slope is relatively small. It might be rise 1, run 3. The slope of this line might be 1/3. But at a different point as we go further along, this is a slightly steeper slope. We might rise 1, run 1. This slope might be 1/3. This slope might be 1. As we go further, you rise 2, run 1. Here the slope might be 2. Do we see what's happening is the slopes of the tangent lines are increasing. The slopes of the tangent lines are increasing. But in this scenario, here, the slope of this tangent line, let's say we go up 1 over 1. So the slope of this line might be 1. But here, we rise 1, run 2. The slope of this tangent line might be 1/2. And then here, that we rise 1, run maybe 5. The slope of this tangent line might be 1/5. And so if the curve is concave down, we see the slopes of the tangent lines are decreasing. Here, slopes of the tangent lines are increasing, slopes of the tangent lines are decreasing. Well, we know how to represent the slopes of the tangent lines. The slopes of the tangent lines are given by the derivative. So when we say the slopes of the tangent lines are increasing, we really mean the derivative is increasing. And when we say the slopes of the tangent lines are decreasing, what we mean is the derivative is decreasing. Well, what do we mean when we say a derivative is increasing? A derivative is increasing. Well, any function is increasing if its derivative is greater than 0. What is the derivative of the first derivative? Yes, it's the second derivative. So the curve is concave up if the derivative of this function is greater than 0. That means the curve is concave up if the second derivative is greater than 0. And then exactly the same, a similar argument over here. The curve is concave down. That means that the slopes of the tangent lines are decreasing, which means the first derivative is decreasing. A function is decreasing if its derivative is less than 0. What is the derivative of the first derivative? Yes, it's the second derivative. So the first derivative is decreasing if the second derivative is less than 0. Well, let's eliminate the middleman. If we take this piece out of the puzzle, just leave this out, the curve is concave up if the second derivative is greater than 0. The curve is concave down if the second derivative is less than 0. When we're dealing with concavity, when you're dealing with concavity, the first derivative does nothing except as a stepping stone to get to the second derivative. So you'll be given a function f. You'll be asked to analyze concavity or to consider concavity. The only thing the first derivative does is act as a bridge, a stepping stone, to get to the second derivative, and then the second derivative is used to analyze the concavity. Once you've found the second derivative, this first derivative has nothing to do with the analysis of concavity. First derivative is used to analyze increasing, decreasing. Second derivative is used to analyze concave up, concave down, concavity. And then the function itself is greater than or less than 0, determining whether it's above or below the axis, the x-axis.